Hi everyone. Today we're gonna we're gonna go ahead and be working around some major concepts around like some foundational pieces of fractions, and that's the idea of like fractions that are equivalent to one, and then fractions that are larger than one, and the different names we use for those. So mixed numbers and top-heavy fractions. So we're gonna kind of get into this and like break apart like really the deeper understanding of what fractions are, what they mean, and how we can see them in all of these different equivalent ways. So let's start with that first piece of the idea of a unit fraction. Remember that term unit fraction refers to one piece of it. So that unit fraction will always change. In fact, fractions are always different based on how you decide to cut a number up, right? So I'm gonna ask you to try to visualize this with me. Not that though. Right, so here's the number one. So now we're just gonna visualize the idea that we need to draw a model that represents one. Okay, so here's my rectangle. As I said, drawing rectangles I find is a lot easier to make sense of this kind of work. Okay, so like we just have to imagine that one is being chopped up. And to help me visualize that, I'm using a rectangle to represent the number one, right? So if I cut this one up, right, if I partition it into equal pieces, and let's see, I'm actually going to do it like this. So if I partition it into these pieces, you'll see that I start to get, first of all, a fraction, right, a fractional part, and then I get the unit fraction. So remember, with a fraction, the denominator is all the pieces that I just cut the number one into. So you can see I have 1, 2, 3, 4, 5, 6, 7, 8 equal pieces. So that becomes my denominator. Now, each one of these, right, each one of these represents one piece. So this is one piece out of the 8. This is also one piece out of the 8. This is also one piece out of the 8. And this is also one piece out of the 8. And so on, like that trend continues. So each one of these is its own one piece of 8. So that's the unit fraction, right? The unit fraction, I guess we'll write the whole word. The unit fraction is 1/8. 1/8, 1 out of 8. That's the one piece that makes it. And we've been learning that we can compose or decompose these models by adding or subtracting these unit fractions to get answers. So a further example of all of this might be if I was to go and shade in 1, 2, 3, 4 of these, right? That would be 1/8 plus 1/8 plus 1/8 plus 1/8. There's 4 of them. And if I had 4 pieces of 1/8, I'm going to get 4/8, which is actually the exact same thing we see in the picture, is that now I have 4 out of my 8 shaded in. Okay, so there's just like the beginnings, right? This is what we've talked about, unit fractions, what they mean, how we break things apart. And again, visualizing in this case, we're using the number 1. Now, when we want to talk about fractions that are equivalent to the number 1, it's pretty cool because what that really does mean, and that's, I guess let's do another page for that. So fractions equivalent, I love this word in math, to 1. So remember equivalent, you know me, I'm always going to talk about it, same value. So it's worth exactly the same, but it looks different. Which is true because what we're going to do is we're going to have the number 1 and then we're going to think about, well, what fractions would be equivalent to that 1. They would have the exact same value, but they would look differently. So let's start with this. I'm actually going to erase that because it was a horrible model and I'm going to redraw it. And of course, there's probably going to be a screen glitch because I changed colors. Yeah, there you go. Okay. So here's my model. And again, when I think about how I took this number 1, I can cut it into as many pieces as we want. So for starters, let's just go here. All right. So I've cut it into 3 pieces. That's very obvious there. I see 3 pieces. and each one is 1 out of 3. So there's my unit fraction of 1/3. But if I wanted this to be a fraction that equals 1, remember then that means I need all of these pieces. I need all of them to complete it, to make the complete 1. Just like when you order a pizza and it shows up and it's cut into slices, all the slices are there, so you have 1 whole pizza. If you ordered a pizza and you opened it up and 3 slices were missing, you'd be very upset with whoever brought that pizza to you or whoever you ordered it from, because it would not be complete. You actually wouldn't have 1 pizza. You'd have less than 1 whole pizza because someone ate some slices on the way to deliver it to you. So if I want all 3 of these, that means I need to think about this concept that I need to shade in all 3 of them. So that means I have 1/3, right, plus 1/3. So that's 2/3 plus 1/3, which equals 3/3. So that would be true. 1/3 plus 1/3 plus 1/3 equals 3 out of 3. And what that means is that 1, an equivalent fraction to the number 1, is 3 out of 3. So that's how we show when people talk about, oh, what's a fraction equal to 1? Well, here's 1 fraction equal to the number 1. 1 is the same thing as 3 out of 3. So let's go further with that. And again, let's stick with the number 1 because that's what we're doing. We want something that's equal to 1. So this time I'm going to draw another model, but instead of cutting it into 3 pieces, let's say I cut it into 4. Okay, so again, my fraction unit, this is 1 out of 4. This is 1 out of 4. And this is 1 out of 4. And this is 1 out of 4. Do not like the way that looks. Hold on. Let's change colors, even though I know that's going to cause some sort of weird glitch on the screen. Is the new norm for these videos. Oop, there it is. Okay, so 1 out of 4, 1 out of 4. These are the unit fractions. The unit fraction is 1 out of 4. And again, I know that if I want this equal to 1, then I need all of it. I need this 1/4 plus this 1/4 plus this 1/4 plus this 1/4. Like I need all of them. So we could shade those in to show that. So 1, 2, 3, 4. And when we do that, again, we get 1, 2, 3, 4 pieces out of 4 pieces. So 4 out of 4. So actually another fraction equivalent to 1 is 4 out of 4. So we know that 3 out of 3 equals 1 as a fraction. We know that 4 out of 4 equals 1 as a fraction. What if I took the number 1? Again, I'm going to need a model. And instead of cutting it into 4 pieces, I don't know, let's cut it into 6 pieces this time. Okay, and then let's think about what our unit fraction is. Right, this is 1 out of 6. 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 And if I want all of it, I would have to take 1 out of 6 plus 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 1 out of 6. So of course we're going to have to shade those in. So 1, 2, 3, 4, 5, 6. And if you put all those together, it should be plus 1 out of 6. We're going to get 6 out of 6. So there's another fraction that's equal to 1. And I hope at this point what you're starting to see is this pattern and this understanding of fractions and what they mean. Any fraction that has the numerator and the denominator exactly the same means I have every piece, which means I am equal to 1. Okay, kind of pause there to make you think about that. So if we take that and put it into some perspective, then we could say, all right, well, what if I had 30 over 30? Well, guess what? That's equal to 1 whole. Because if I was to take a model and cut it Oh, this is gonna be crazy. Cut it into 30 pieces. So let's see, 1, 2, 3, 4, 1, 2, 3, 4. Right? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. Yeah, that's 30 pieces. Wow, I did that. Cool. And then I shaded all of them in, meaning I have 30 out of 30. Then I have one whole box filled, which is the same thing as the number 1. So the whole trick here is that a fraction that's equal to 1 is really any fraction that has however many pieces it's cut into, and it has all of those single pieces. So 3 out of 3, actually I think we did that one, equals 1. 5 out of 5 is equal to 1. 6 out of 6, we probably already did that, equals 1. 100 out of 100, that equals 1. 1,250 out of 1,250 equals 1. And what's really cool about why this is, like, we already saw the model reason of it, right? How I could take a number and cut it into as many pieces as I want. And we're also realizing the more pieces I cut it into, the smaller those pieces get, right? So like if I took 1, I'm not even gonna do it, and I cut it into 1,250 pieces, right? Like you have to imagine those would be the tiniest little pieces that I'd have to cut it up into. This would be so small, right? That's not even accurate. Those pieces aren't even equal, but that gets the point, right? That would be like if you had to share a pizza with 1,250 people. I mean, I don't even know if you get a piece of cheese if that was the case, right? So however, it doesn't matter however many we cut it up. We can take the number 1 and cut it into as many pieces as we want. And as long as we have all of those pieces, then we have the number 1. And another reason behind that, why we want to talk about that, is this idea of what a fraction really means. This line we've been talking about, this let's try that again, this out of line that we've been saying, right? This says 6 out of 6. It actually also means division. That's what you're actually doing. You're taking something and you're cutting it up. That's what you mean to divide, right? Fractions are related to division because you're dividing things. You're cutting them up into pieces. And so if you think about what this actually says 6 is divided by 6, and any number divided by itself equals 1, which is why, again, 37 out of 37 really means 37 divided by 37, which really just equals 1. Or that 1,982 out of 1,982 really just means 1,982 divided by 1,982 equals 1. So to get a fraction that's equal to 1, all you need to ever think about is making sure that your denominator and your numerator are exactly the same. And if they are, then that is all of your pieces, which means it's actually just 1. Pretty crazy, huh? If you think about it, like if you had something and you cut it into 1,982 pieces, right? And then you had all of those pieces at the end of the day, that's actually only equal to the number 1. Because remember, a fraction is all about the pieces you cut it into. So pretty fun stuff. Okay, so I know that at the beginning of this video, we promised fractions larger than 1. We're not even going to get to that in video. You're going to have to watch that in the next one because I want to be aware of time so that you're not always watching one video forever. So there's fractions equal to 1. Go ahead and tune in to the next episode where we will be talking about fractions larger than 1. We'll see you soon.